So this is National 4, National 5 Chemistry, and we are looking at Unit 3, which is Chemistry and Society, and the topic is fertilizers. This will be the last lesson on fertilizers, and what we're going to look at is how to calculate percentage composition, and there will also be a set of summary revision questions of all the topics at the end. So, the aim of today's lesson is to understand how to calculate the percentage composition of elements in fertilizers. And so this topic, calculating percentage composition, will also be looked at in Unit 1 in the calculation section. So some of this may be revision to you. So the success criteria to be able to calculate the percentage composition. Now, ammonium salts, potassium salts, nitrates and phosphates make good fertilizers because they contain the essential elements N, P and K. And also those salts are soluble and pass easily into the soil and up into the plant's roots. Those are the two requirements to be a good fertilizer. You need to contain at least one of phosphorus, nitrogen and potassium, and you need to be soluble. Now, the percentage of a particular essential element in a fertilizer can be varied. And the reason you would want some variation is because different plants will need different amounts of each essential mineral. So some plants might need more nitrogen than others, some might need more phosphorus. So it's necessary to have a whole range of fertilizers that come with different percentage compositions of each of the different elements. Now, percentage composition is a way of allowing us to calculate the percentage of an element present in a compound. For fertilizers, what we would be looking to calculate is the percentage of nitrogen, the percentage of phosphorus, or the percentage of potassium in a fertilizer. So we're going to do 3 examples. The first one is calculate the percentage of nitrogen in ammonium sulfate. And you've been given the formula. Ammonium sulfate is NH4,2SO4. So step 1, you need to write out the formula, and you've already been given that. You may just be given the name of the compound, and then from the name of the compound, you might have to calculate the formula. The next thing you need to do is calculate the formula mass, otherwise known as the gram formula mass, or GFM. To do this, you work out how many there are of each element and multiply it by the mass of each element. You would find the mass of each element in the data booklet on page 7. So for this one, there are 2 nitrogen atoms, so that's 2 times 14. There are 8 hydrogen atoms, so that is 8 times 1. There's 1 sulfur, so that's 1 times 32, and there are 4 oxygens, which is 4 times 16. When you add all of those together, you find out that the gram formula mass of ammonium sulfate is 132. Now we need to work out the mass for the required element. Now the required element we've been asked for is nitrogen, and we know that there were 2 nitrogens in the formula. 2 times 14 is 28. That is our mass of nitrogen. Percentage composition is mass of element divided by total mass, and then multiply that by 100. So we're going to have 28, which is the mass of nitrogen, divided by 132, which is the formula mass, and multiply that by 100, which gives us 21.2%. Remember to put the percentage sign on if it is a percentage. So this is one that you can try yourself. Let's calculate the percentage of potassium in potassium phosphate. If you're not confident to try it on yourself, just keep watching the video. If you do want to have a go at it yourself, I suggest that you pause the video now, have a go, and then resume the video. So for those of you who have just resumed the video, we're going to go through the answer to this one. So percentage of potassium in potassium phosphate. Well, the formula is K3PO4. So the next step is to work out the formula mass. We have 3 potassiums, which is 3 times 39. We have 1 phosphorus, which is 1 times 31. And we have 4 oxygens, which is 4 times 16. That gives us a grand total of 212, and that's the formula mass. Our mass of potassium is 3 times 39, which gives us 117. And to work out our percentage, it is mass of the element we're after, so that's 117, divided by the formula mass, which is 212, and then multiply that by 100, which gives us 55.19 or 55.2%. Next example that you can try yourself is to work out the percentage of nitrogen in ammonium nitrate. Again, pause the video and have a go. So if you are joining us after having had a go, well done. We're going to go through it. So the first thing is the formula is NH4NO3. Now the formula mass, we have 2 nitrogens. So remember this N symbol appears twice. So we have 2 nitrogens, so that's 2 times 14. We have 4 hydrogens, which is 4 times 1. And we have 3 oxygens, which is 3 times 16. When we add that together, we get 80%. Now the mass of nitrogen in the compound, remember there are 2 nitrogens in the formula because nitrogen is written twice. So it's 2 times 14, which gives us 28. Then whenever we're working out the percentage, it is 28 divided by 80 multiplied by 100, which equals 35%. And you can see that exact question came up in a past paper. So that would have been 35% again. So here's another example. You might need to give yourself time by pausing the video to do this, but it's calculate the percentage by mass of calcium in fluorite, which has a formula CaF2. So for this one, the percentage of calcium, well, calcium has a mass of 40 and there's only one of it, so it's going to be 40 on the top. And the formula mass is calcium plus 2 fluorine, so that's 40 for calcium. Fluorine has a mass of 19. If there's 2 fluorines, that's 38. Add them together, 78. Our percentage calcium is 40 divided by 78 multiplied by 100, which gives us 51.3%. Here's another one. Anglesite is an ore containing lead to sulfate. What is the percentage by mass of lead in anglesite? Again, you might want to give yourself some time to do this question by pausing the video. For this one, the percentage of lead in the compound is 68.3. That's because the mass of lead is 207. The formula mass of lead sulfate itself is 303. 207 divided by 303 equals 68.3%. So hopefully at this stage you are able to calculate percentage composition. So we're going to get into these revision questions now. So which one of these salts would not be used as a fertilizer? And my advice is that you're going to need to use, you might need to use your data booklet for this one. Now for this one, the answer is C. And it's C because remember, a fertilizer, you need to contain sodium, phosphorus, or potassium. And sodium chloride, to be a fertilizer, you need to contain nitrogen, phosphorus, or potassium. And C doesn't contain any of those, it's sodium chloride. Ammonium chloride contains nitrogen, ammonium phosphate contains nitrogen and phosphorus, and sodium phosphate contains phosphorus. Sodium chloride does not contain any of the necessary elements. Which metal is used as the catalyst in the industrial manufacture of ammonia? Well, the answer to that one is iron. Remember, the process for making ammonia is the Haber process. Haber begins with H, next letter is I, which is iron. So we have got an equation for the production of ammonia from nitrogen and hydrogen. And it says that we've got this symbol where we've got an arrow pointing in both directions. What does that symbol indicate? that symbol indicates that the reaction is reversible. So we've got which one of these is not an essential element for healthy plant growth? Oxygen, nitrogen, potassium, or phosphorus? The answer, of course, is oxygen, because the other ones are NPK, and the essential elements. Now, the Haber process is the industrial process for the manufacture of what? Nitric acid, ammonia, alkenes, or esters? Well, the answer is ammonia. Now, a fertilizer for tomato plants contains compounds of phosphorus and potassium. Suggest an experimental test, including the result, to show that potassium is present in the fertilizer. And it's suggesting you might want to use the data booklet to help you. If you're trying this at home, I suggest that you look at page 6 of the data booklet. So for this one, the answer is to do a flame test. And potassium compounds, if you do a flame test and there's potassium in the sample, the flame will turn a lilac colour. And that is written on page 6 at the bottom. So if you ever forget the colours for a flame test, they are in the data booklet, page 6. So ammonium citrate is included in the fertilizer because some phosphorus compounds are more soluble in ammonium citrate solution than they are in water. Suggest another reason why ammonium citrate is added to the fertilizer. Well, ammonium is made from nitrogen, and so adding ammonium citrate adds in another essential element, nitrogen. So we've got another question here. We'll do each one in turn. So the first one, you've got the conditions for producing ammonia. Name the catalyst used in this process. Well, the catalyst used in the production of ammonia is iron. Now the next question is a problem-solving question. You've been given information in a table at how pressure is affecting the percentage yield, and you're asked to predict the percentage yield of ammonia at 700 atmospheres. So for this one, you would have been allowed to give any answer between about 52 to 56. And that's because if you look as you go up 100 atmospheres in pressure, you seem to be going up either 8 or 6 each time. And then if you're going from 500 to 700, you're going up by 200. So you'd either be going up by about 12 or about 16. So either 52 to 56 for that one. Fertilizers are added to soil to provide essential elements required for healthy plant growth. Nitrogen is an essential element. Name one other element required for healthy plant growth. Well, we're looking at we're not looking for nitrogen, we're looking for potassium or phosphorus. And then some compounds do contain essential elements but are unsuitable as fertilizers. Why might that be the case? Why might a chemical be unsuitable for being a fertilizer even though it contains an essential element? The answer to that is they might not be soluble, because remember, fertilizers must contain an essential element and they must be soluble. For these questions, you probably will need to pause the video to give yourself time to calculate them out. For this one, calculate the percentage of potassium in potassium sulfate. So hopefully you've taken some time to answer that one. To do this, the final equation you should have come to was 78 divided by 174, which gives you a 44.8% of potassium. Next one, calculate the percentage by mass of lead in galena, which is PBS. And you will need to use the data booklet for this one, and pause the video to give yourself some time. But the answer to that is And it should have been 207 divided by 239 multiplied by 100, which gives us about 86.6%. And our final question is, you've been told that the composition of a magnet, so a magnet weighs 250 grams. You've been given the percentage of different metals, and you've been asked from a percentage to calculate the mass. So what is the mass of aluminium in a magnet that has a mass of 250 grams? So this is a problem solving question. And for this one, well, the percentage of aluminium, not lead, don't know why lead's written there, but percentage of aluminium is 10%, so that's 10 divided by 100. And then you have to multiply it by the mass of the magnet, which is 250 grams. And so 10% of 250 is 25 grams, which is the mass of aluminium in the compound. Apologies for lead being written there. So that is a summary of all the sorts of questions on fertilizers that you're likely to get in an exam. And that concludes all of the fertilizer topic. So thank you for your attention.